The department is also home to several research scholars pursuing their doctoral degree. Further, students from various countries across the globe intern for a semester in the department through the IAESTE program. Students are also encouraged to take up industry internships, resulting in a number of core and product-based company placements. The department also houses state-of-the-art labs with the objective of developing innovative ideas and achieving excellence in research and training industry-ready professionals. The lab contains industry-standard VLSI EDA tools such as TCAD and Cadence 11 Lab, which is a single machine that can perform all the required steps to create an antenna or a prototype PCB board. A center for research in semiconductor devices used extensively for fabrication and modeling of semiconductor devices has also been established in the department. Collaborative research projects are carried out with the Department of Space, ISRO, and the Ministry of Defense, DRDO, in this center. The IoT Center is equipped with the latest chips provided by IoT giants like Texas Innovation and Intel Intelligent Labs to develop systems for solving societal problems. In placement training, the focus has been on analog, digital, and radio frequency circuits, communication and signal processing, VLSI and embedded systems, networking, computer vision and image processing, control systems, robotics, and nanotechnology. Emphasis on industry internship has resulted in core and product-based company placements. Few of the top recruiting companies of the year are Tata Elxsi, Accenture, Zoho, Wipro, Infosys, CGI, Indus TechSite, Test and Verification Solutions, Jasmine Infotech, Leica Wireless Communications, etc.
Sir,
Jenkins,
speaker வந்துட்டாங்க சார்.
இன்னும் வரலன்னு நினைக்கிறேன். ஒரு 2 minutes. We'll wait for 2 minutes.
ஓகே.
Hello, Dr. Utku. Dr. Utku, can you hear me? Dr. Utku, Jenkins,
Sir.
is my voice audible?
Yeah, yes, sir. You're audible.
I think he is online.
Yeah, yes,
Hello.
Yeah, hello. Good morning. Sorry, I was just
Good morning, Dr.
the webcam and the microphone and my Windows, my operating system just started to perform an update. Sorry for that, and I was waiting for it. I hope you are fine, dear Jude.
Okay.
Yeah.
Yeah. Everyone fine. Just 5 minutes
Okay.
or two. I'll give a small introduction. Then you can start your presentation.
Okay. No problem. Sure.
Welcome to India virtually.
Yeah, thank you very much. I hope I will also be in face-to-face modes in the following months and time.
Yeah, sure.
Yeah, thank you very much for your kind
Welcome,
invitation.
participants. Welcome, participants. Today is the penultimate day of our 5-day FDP. Thank you for joining us today also. So before going into the speaker, Dr. Otkokos, I will just give us some hello.
Yes, sir.
Is my voice audible?
Yes, sir. Now you're audible.
Yes, now it's
Sorry, there is some network issues on my side. Okay.
Okay.
Before going into the agenda for today's session, I'll just give a summary of what we learned last session. Just I want to give some tidbits or foods for your thoughts. Right? I would like to stress on 3 important points. So many of the participants yesterday asked about how to manage with the image formats. So whenever we go for medical images, we normally prefer DICOM formats. The reason is when we go for TIFF or BMP or JPG, there will be loss of information. But the question I have in my mind is, throwing a challenge to is, deep learning or our convolution neural networks detect objects based on the edges, right? You would have remember the second day session by Dr. Clement when he posts some kernels or masks where vertical edges and horizontal edges are going to be detected. So if edges are important to us, will this JPEG compression affect the edges? So when you say what is an edge in an image, you have an image, background you have full white, and if you have a circle with a black color, then that circle is the edge. In other words, the highly distinguishable change in the intensity levels of an image can be called as an edge. But when you go for JPEG, TIFF, BMP, the intensity level may change, but will there be any significant change in the edges? Right? I think still CNN may work with your JPEG or BMP or TIFF images. You can give a try, right? So why I'm stressing on that is, if you go for MATLAB or any other programming tool which can read these JPEG or compressed images, you can have your own contribution. However, if you use the inbuilt comments, your contribution may not be new. The second point I want to stress on is you need not give the entire images training to the CNN or any other networks. Even you can give a patch of portion of an image, which seems to be more effective. If you have an expertise, knowledge, or idea about that, you can make use of that too. So these are the 2 important points I want to stress so that you will get a new novel idea or novel contributions from deep learning approaches. So that is what I want to say. Now, different people think differently, right? Um, Depending upon the geographical location of the people, they have their own necessities. The database will be different. The way in which they go for programming the software, the resources may be different. So with that objective in mind, today we are going to have a Turkish flavor in our FDP. I welcome Dr. Utku Kos from Süleyman Demirel University for this FDP. And he is one of the pioneer in Turkey with lots and lots of research publications and projects and all other research activities. And more importantly, he's a Mr. Nice Guy. He and his wife are very close to us, family, friends. Thank you, Dr. Utku, for accepting my invitation. I know your schedule is extremely tight. So still you have accepted our invitation and ready to share the thoughts with our participants who will be definitely benefited out of you. Now I request Dr. Jenkin to give a brief introduction about Dr. Ukku.
Thank you, Professor Jude. There is an old Turkish proverb which goes like this: a small key opens big doors. We hope that every single day we are holding a window of opportunity to explore our incredible potential to grow better. Hello, everyone, and welcome back. We are happy to have you with us today in our session. Myself, Dr. Jude and Jenkin and Dr. Anushya will be your moderator. We all work with Karunya Institute of Technology and Sciences, and we are excited to be hosting this session today. If you have any questions to our speaker, please feel free to send it through the chat box, or you can come over live during the question and answer session. We'll have an interaction after the speaker's presentation. Right. I'm pleased to introduce today's speaker, Dr. Utku Kos. Dr. Utku Kos, who will be sharing his thoughts on deep learning for cancer diagnosis today, holds a PhD in computer engineering from Selçuk University, Turkey. He started his career as a research assistant in Afyon Kokitep University between 2009 and 2011, later as a vocational school vice director in Afyon Kokitep between 2011 and 12, and then in research center as a research center director in Uşak University between 2012 and 17. Presently, he is associated with Süleyman Demirel University, Turkey, as associate professor. He has more than 100 publications, including articles, authored and edited books, proceedings and reports, which has accounted in more than 1,000 citations. He is also in editorial boards of many scientific journals and serves as one of editors of the Biomedical and Robotics Healthcare book series by CRC Press. He holds a Turkish patent on touchscreen writing drawing systems. His research includes artificial intelligence, machine ethics, artificial intelligence safety, optimization, the chaos theory, distance education, e-learning, computer education, and computer science. He is also more familiar in national TV programs discussing on topics like AI and COVID-19, cybersecurity, and video games. He is a topper in academics, and he has been recognized with several awards for his works like Young Scientist Award, Lifetime Achievement Award, and Top Reviewer. We would love to hear from you, Professor Utku Kos. I now hand over the mic to Dr. Utku. Thank you for joining.
Thank you very much. Thank you very much, dear professor. I'd like to thank, first of all, would like to thank my valuable colleagues from the Department of Electronics and Communication Engineering of the Karunya University, and as well Professor Jude Hemant for his kind invitation to perform such a valuable and important and timely FDP and keynote speech in terms of an international touch with all of your valuable participants. I hope you will all enjoy my speech, which is based on the cancer diagnosis by using deep learning. And I'd like to also congratulate all of you and everyone taking important place in realizing such 5-day FTP and providing and ensuring valuable international speakers from different regions of the world. And I'm also looking forward for having more collaborations with the valuable colleagues from Department of Electronics and Communication Engineering and also Carolina University. Yes, dear professors have just made a great introduction about me and also about the topic based on the deep learning, use of AI and the advanced mode of the deep learning. And I will just make a presentation on how we apply deep learning and the associated techniques and as well as the methods regarding that subfield of machine learning for cancer diagnosis. Yes, I'm sharing my screen. I hope you will see my desktop as well. Yes, I think you can see my presentation now. If you encounter any problems, just inform me, so I will try to solve.
Yes, it is visible. It is visible.
Yes, it's visible. Okay, okay, dear Jude, thank you very much. Yes, as I've said, the deep learning and also dear Professor Jude, Professor Hemant has indicated that the use of deep learning and that advanced mode of machine learning is very important in the terms of especially the real world problems of today's modern life. And at this point, the cancer diagnosis takes an important place in terms of especially medical research works. And if you are performing different research works or ensuring different research-oriented systems developments, you will probably be encountering with deep learning techniques. There are lots of different techniques in the context of deep learning, and we are all using them for analyzing especially big forms of data. And that doesn't mean the amount of the data, but we also talk about the complexity level and also the source of the data, for example. So we all, as the AI experts around the world, we are all enrolled in different research works using deep learning techniques. And when we come to a important and remarkable topic in terms of medical research, we always reach to rare disease diagnosis and also cancer diagnosis, which takes a very important place in terms of current developments, current advancements, and also future research works of deep learning. And it seems that deep learning has a great importance in for not only nowadays of the field of AI, but also its future state. Yes, I would like to also introduce my presentation contents. I will just talk about briefly about what is AI, and after that I will consider the machine learning and deep learning and their differences. I think the speakers made presentations before me have already given an idea about what is ML and what is deep learning. But I will also share my knowledge and my ideas regarding them. And after that, I will move to deep learning for cancer diagnosis topic. And by discussing about them, I will also give some ideas about future scenarios and also open problems in the context of using deep learning for cancer diagnosis. After that, I will also give some suggestions because I know that many valuable students, our friends are listening to us. So I will try to open some minds regarding how to apply deep learning for cancer diagnosis. And I think my ideas and also suggestions will also affect the way of not only learning about deep learning, but also shaping your knowledge and abilities, development abilities for the research works regarding the field of AI. And at the end of my presentation, I will take your questions. Yes, before starting, dear Dr. Winston has just introduced me, but as you can see, there are also some of my academic profiles. You are all free to visit them. You are all free to visit my personal website to be informed about what I'm doing in terms of research works. Recently, I'm also working in the context of medical research, where I'm using deep learning or different AI-based techniques, including optimization or other hybrid methods. So you are all free to visit my academic profiles as well as my website, personal website, to learn more about me. The rest of has already introduced by dear Dr. Winston, so I'm passing here. And I would like to also give some information about my hometown and also Sparta. Dear Professor Hemant already knows about Sparta. As he indicated, we are close friends in terms of family members also. So it was a great session, keynote session provided by Professor Hemant last year in an international event realized by our department. And the Professor Hemant has provided a great support and efforts for having a successful event in terms of especially in AI and computer engineering and many other engineering fields in terms of using the field of AI. And during that event, we have visited many places in Sparta, in the city of Sparta, where I am currently living. And I hope we will all again be together in Sparta, or maybe next time I will be visiting India after that the issue of COVID-19 is past. But I always invite all of you, my friends from India, to visit Sparta and also my hometown, Afyon. And we are all free to visit the other beautiful cities of Turkey. I hope Professor Hemant enjoyed his stay last year in Turkey, and you are all welcome to visit many different places of cities of Turkey. It's a beautiful country, including many beautiful cities. So this that region, as you can see, some red squares are all places, all cities I'm performing my academic career. Actually, I have completed my Bachelor of Science at the capital city of Turkey, which is called as Ankara. After that, I moved to Afyon, where my family lives here in currently. And also I moved to Uşak to perform my academic career as a lecturer. And after that, I moved to Sparta, to the Department of Computer Engineering of STU in 2019. 17, and at 2019 I become an associate professor, and that's all. Let's see if I will move to another city or another country, maybe, I don't know, but currently I'm an associate professor at the Department of Computer Engineering in Sparta. Sparta is very famous with its roses and green areas, and also it's located in the a region called as the region of the lakes, because there are lots of lakes here. Also, Professor Hemant is probably remembering that we visited Eğirdir, as you can see on the left down corner side of the presentation. It's a very beautiful place to visit. So we are all welcome to visit Sparta. Also, if you will have enough time, we will have going to my hometown, especially, but we were at Antalya, to the seaside of Turkey, for realizing the event. And after that, we have moved to Sparta with Professor Hemant and his family. But if we will have time, we will have visiting my hometown, which is important for especially starting of the independence war of the Republic of Turkey, and it has a great historical place in terms of that independence war. And there's a big rocky castle located in the middle of the city, and that city is also important and famous with lots of different historical places. So you are all visit the both cities in Turkey. And when we talk about my university, you can see there's a rose over the logo of the university, because we are all famous with the roses. There are lots of shops and many different products regarding the rose. And Süleyman Demirel is one of the previous presidents of the Republic of Turkey, and he was born in Sparta, so his name appears over the name of the university. Our university is a public university, as located in Sparta, the city of Sparta, and as established in 1992. We have around 70,000 students currently, and we are known as a large academic institution with that number in Turkey. And we are also famous with our programs in agricultural research, medicine, engineering, and also business science. And when we come to our departments, Department of Computer Engineering, we have currently 3 professors and 2 associate professors, as I am one of them. And also we host 8 assistant professors and 2 research assistants. And we have 3 different working areas of computer science, computer software, and computer hardware. And we also host 3 different degrees of Bachelor of Science, Master of Science, also PhD degrees. And we also have many international students coming different regions of the world. So at this point, you are all welcome to visit our department and also perform your degrees, especially and in exact from the performing degrees. Also, my colleagues and our student friends are also all welcome to our visit our city, our university, and also our department. We are especially focused on the research works of AI as it's happening around the world. The field of AI is a very important trendy topic, as you know. But we also have many different academicians in the university collaborating with us with our department. So we form a big team in the context of research works, which are also especially including the field of AI. So you are all free to visit us. Yes, let's start. I would like to also give a brief information about what is AI. I think everybody knows about that concept and also the field, what that field means in terms of research works in the context of computer science. But I would like to make a presentation which includes both technical details, enough details, and many other informative things to make everybody, including starters, beginners, and also um, maybe intermediate level friends to learn enough about what is AI and what is the role of deep learning in terms of cancer diagnosis. When we talk about AI, we should be calling Professor John McCarthy to define the concept of AI. He says it's the science and engineering of making intelligent machines, and we know Professor John McCarthy as the father of that concept. You may already been hearing about the Professor Alan Turing, which have developed the electromechanical device to solve the problem of the Enigma by Germans during the Second World War. But the father of the concept, the exact father of the concept, or the scientist who has coined the concept of AI is Professor John McCarthy. During a conference in Dartmouth, USA, he has just introduced the concept of AI, which means science and engineering of making intelligent machines. For now, we should be defining the concept of AI by including or combining many different components to define the way of the AI, the way of how it solves the real world problems, and the way of how it interacts with different supportive technologies, shaping our especially daily life. We can say that the field of AI is somehow a simulation of humans, animals, and nature because there are lots of techniques inspiring from different components of the real world, and by using some metaphors and also some inspirations from the nature, including us as the humankind, humans, and also animals, and many repetitive occurrences, dynamical things occurring in the nature. We just form some automatically problem solving techniques to perform or realize technology-based intelligence solutions. And by using such solutions, we just try to improve effectiveness and efficiency of the real-world problems and also solutions for them. And because of the flexible nature and also advanced modes of the techniques in the context of AI, we can say that there is no field where the field of AI is not used widely, because for now it's applied in all fields of the modern life, including even music, literature, education, and many other fields. And because of that, we can say that it's the science of the future shaping our future. And also because of its multidisciplinary perspective, we can say that it employs a great potential for not only today's world, but also for the near and the far future of the humankind. When we talk about the computer applications, we can say that they are just some algorithmic steps which are especially somehow an interface between us and the computer-based systems. But when we come to AI, we can say that it's an interface between human and the machine. When we talk about in terms of, for example, robotic system, we can say that we just realize something algorithmic to perform or to develop or design something intelligent which can use somehow mechanisms and features of a middleware to ensure enough interface features and methods or solutions to make something automatically solving your real world problems. So that's the AI, that's the concept of AI, and that's the field of AI. Just we use lots of different techniques and solution components to rise some intelligence systems. And there are especially mathematical and logical algorithms lying on the background of all of these solutions. But when I talk about something regarding AI, I see, especially from our students, that many of our students are fear of the mathematical and logical background lying on the background of the AI techniques, but do not fear about them. But just try to understand the general logic which is used in terms of machine learning or maybe intelligent optimization, depending on the different subfields, sub areas of the field of AI. So don't fear about them, but try to understand the logic on the background. And after a while, you will be all comfortable to understand enough about details of the AI. When you want to be an academician and scientist or the expert in terms of AI, you will probably be needing to learn more about the mathematical and logical details. But the more you write some codes, the more you work or the more you perform some research works in terms of AI, you will be all comfortable to understand enough about mathematics and logics on the background of AI. So don't be fear about them and just enjoy learning the field of AI. And as you already know from the news, from the many web sources, there are lots of discussions regarding the future of AI. So everybody asks that if that field will be an utopia or dystopia for the humankind, for the world. So we should be asking that if it will be a technological risk or threat, and if it will be or not a cause of extinction. So there are lots of different research orientations in terms of providing safe AI systems and also providing accurate or effective solutions for certain problems, including, for example, medical, that we will be talking in that session, or many other problems having great importance in our daily life. So any of harmful or dangerous state that may affect to have side effects for us are important issues, important discussion, the origins. So there are lots of discussions regarding future of AI. So we should be asking that if it will be a science without human. I can say that it's already a product by the humans, by the humankind. So we cannot say that it's a science without human. We should be just careful against not leaving the AI by itself to develop or to evolve itself by its own efforts. But I think that in terms of a theoretical manner, it's possible to have dangerous intelligent systems for the future, but as well as, or as long as we control the developments of or advancements in terms of the field of AI, we will be all able to control that improve level, and also we will be all controlling the features. So that's all us, that's all the humankind who will be having the responsibility to having harmful or useful intelligence systems for the future. So by also considering the supportive technologies such as electronics, computer systems, computer-based technologies, and communication technologies maybe, or many other components of data science, we should be saying that the field of AI is not a science evolving by its own efforts, but it's all associated with many supportive components in terms of different technologies. So the future of the AI is or will be always often because of all of these advantages. And because of all of them, it's not a stoppable technology. In contrast, it's a very important scientific field which is gaining more and more momentum thanks to different developments in terms of other supportive technologies and more the adaptiveness level of the humankind, and the more common technological components taking place, more often taking place in our daily life. So the field of AI is not only the science of the present, but also the science of the future, including our near and the far futures, and we will all be seeing how the AI will be affecting our lives in terms of different fields. And when we come to learn talking about the relations of the AI with different fields, we can say that there are lots of different fields, different supportive fields affecting the way of the AI. We can be talking about communication technologies, electronics, cybernetics maybe, and we can also talk about data mining, which has some relations with the AI. We just change our perspective to understand the way of the data mining and the AI. We just focus on the data or the way of the problem solving when we are talking about the differences among the AI and the data mining, but they are all almost very similar fields, including some differences in terms of details. But we should also be talking about robotics, which is very important for the near future. We may be also talking about IoT systems, Internet of Things, many other systems, including smart sensors in terms of communication technologies and their relations with the AI. And we should be all shaping a bigger picture of that schema, as you can see. And there's a great relations among many different supportive technologies as well as the field of AI. And when we talk about especially pre-processing of the data, we should be talking about the data processing side, including image processing or signal processing, for example. So they are all very important components to make the jobs of the intelligence systems easier, to understand more about the target data and to make your problem solution more accurate at the end. And because of that, we should be shaping such a great and big picture of the relations with or among AI and the supportive technologies. But the more you add different components of technological things, the more you get a bigger picture. So it's a very big and great relation in terms of AI and the supportive technologies. And when we talk about machine learning or deep learning, we can say that, as you can see from the schema, from that all of these things located here, you can say that not all of artificial intelligence based techniques are also machine learning techniques, because there are lots of, for example, optimization algorithms coming from the inspirations from the nature, including genetic algorithms, particle swarm optimization, or maybe artificial bee colony, including many the animals and the bugs or insects from the nature especially. So they do not employ machine learning steps, but they just uses iterations to get some values of unknown variables in terms of the mathematical model you just developed for your target problem. So they are not just machine learning, but they are also sub areas of the field of AI. So we should be saying that the machine learning, the field of machine learning is somehow a sub area of the field of AI, and machine learning includes many techniques, including learning and application side of the algorithm. So we just use some samples of data, or just use some learning by doing steps to make our algorithms to be adaptable or to be understanding enough about the target problem before applying it to the target problem in real manner. Of course, there is also the testing side between the training and the application side. So that's similar like us. We are learning something while going to schools and while taking some lectures, reading some books. So that's very similar to the learning nature of the humankind. And there is also deep learning. I will talk about that in the next slides. And deep learning is the subfield of the machine learning, which is the subfield of the AI. So we just form something like that, including especially learning algorithms sides of the field of AI. And when we talk about how we talk about the advancements or the historical flow of the machine and deep learning, we can say that the start of the developments or the start of the AI is just directed by the important developments by Professor Alan Turing, as you know. And just the start of the AI was associated with the idea that any algorithmic or technique or problems solving efforts includes somehow some mechanisms to give the computers to mimic some human behaviors. But in today's world, we should be talking about the field of AI is not the way of the mimicking only human behavior, but also having some inspirations from the nature, including animals and other things. So after the developments in terms of AI at the early, for example, 1950s in the 20th century, we just reached to machine learning, which includes some techniques or algorithmic steps, giving ability to your intelligent systems to learn without being explicitly programmed. So by using them, we just opened a new way of the developments in terms of AI, because machine learning is known as the most important, one of the most important component of the AI, giving that the idea of that we see from the science fiction movies, that there are lots of robotic systems or intelligent systems learning and doing or sensing by their own its efforts, and they have the learning capabilities like us. So the machine learning is just have gained more momentum in especially around 90 and 80s of the historical state of the field of AI. So it was very important in terms of fast developments and fast rise of the field of artificial intelligence in every different fields of the modern life. And we can say that the machine learning systems can give excellent performance in terms of small and medium data sets, and they work on a low-end machine, for example, including a simple laptop, or maybe if we use somehow a strong enough mobile phone, for example, you may even be programming and running a simple machine learning algorithm in it. So we can say that the way of the machine learning for solving your real world problem was an important advancement in terms of the field of AI. So it gave an important momentum for the rise of the AI in terms of our present and the future world. And we can say that, as I've said before in the previous slides, the field of AI needs somehow feature extraction or pre-processing of the data to make their job easier. It's like just our way of learning, because we read something from books, we listen our professors, or we listen our teachers to be adaptable to many forms of information, many complex information, and we just run somehow some supportive components to filter something, filter some information to learn more about or easier about the target problem. So that seems something like a feature extraction we use already in machine learning and also especially intelligent systems. And because of that, we just make sorry, the way of the job of the intelligent systems to be adaptable to different the size of the different problems. So that also allows us to make our intelligent systems to be flexible against different problems. So feature engineering is very important in terms of machine learning. Also, when we talk about execution time in terms of especially today's hardware components and computer-based systems, we can say that from few minutes to hours, we can run any machine learning algorithms to solve our target problem. And in terms of interpretability, some algorithms are easy to interpret in terms of machine learning. But when we come to, especially 2000s, for example, at the start of the 21st century, things have been changed slightly. And for the machine learning, especially the flow of the increased flow of the data has caused some issues in terms of solving, especially real-time problems and also more advanced problem types. So researchers just try to make the way of the machine learning to be more successful against different types of real-world problems. So that caused the rise of another subfield under the field of the machine learning, and we just are calling that field as the deep learning. Deep learning actually, for now at least, just somehow a combinations or collection of different advanced modes of neural networks. We just use them to perform better analysis and better the solutions, better problem solutions over target data sets, including especially big amount of data and complex, high level of complexity, and coming maybe real time in terms of real time with many details. So because machine learning, traditional machine learnings have become not very successful against them, we just reach to many different advanced forms of neural networks, and we just are calling them as the deep learning. And deep learning, because it uses somehow big data sets, it needs more powerful machines, and also for example, use of GPU for solving the target problem. So in contrast to the traditional machine learning algorithms, we just use more bigger level of hardware to run deep learning techniques. And also that's very critical that we do not need to understand the feature extraction or the representation of the data so that we may be running feature extraction, because deep learning techniques and systems include somehow some different advanced problem solution steps to be giving us the ability to make feature extraction before reaching to exact solutions in terms of our target problem. Of course, you are all free to perform some feature extraction just before running deep learning. But when we compare deep learning techniques with the machine learning, you are more able to run the single deep learning techniques, except from searching for any other components for feature extraction before running your exact traditional machine learning technique. And in terms of very big data sets and also needing more powerful machine background, we can say that the execution time of the deep learning maybe up to weeks, up to days, hours, days, and maybe weeks, depending on your target problem, because there are lots of big amount of the data and also detailed analysis of neural networks in terms of deep learning. In contrast to the machine learning techniques that may be taking up to weeks for solving target problems thanks to deep learning techniques. And as I've said before, the machine learning algorithms, some of algorithms of machine learning are easy to interpret, but deep learning techniques seems to be having different levels of interpretability, changing from difficult, to the impossible as the level of the interpretability. And as I've said before, for now, we have somehow advanced forms of neural networks in terms of deep learning, but let's see if the future will be bringing us different types of techniques. For example, in terms of machine learning, we have not only neural networks, but we have also decision trees, maybe support vector machines, Bayesian reasoning, and also concept learning, Q learning. There are many different types of different machine learning techniques having different structures, different problem solution modeling structures in detail. But when we talk about neural networks, especially, we can say that the neural networks is one of the most important, maybe the most successful techniques of the subfield of machine learning under the umbrella of the field of AI. So when we talk about deep learning is just somehow a continuation of the rise of the neural networks, and we will all see if that deep learning will include different techniques having advanced modes of understanding the big data sets, but not using neural network structures, but using or running different problem solution steps in terms of mathematical and logical modeling background. So we will all see. And when we talk about in terms of more details, as I've said before, just there are some feature extraction issues in terms of machine learning and deep learning. Just consider somehow a neural network, for example, in terms of machine learning, we just use an input data to reach to the output decision, including classification, maybe regression, or maybe clustering depending on the data you are using, or maybe reinforcement learning depending on the time and the learning strategy you are just applying, because reinforcement learning is just wants you to make your system to be learning from experiences, giving some feedbacks, including yes, your output is okay, or no, that output or that action is not true, incorrect. So correct your learning sites in terms of learning by doing something and learning from experiences. So we should be just choosing somehow a learning strategy, but out of that, except from the target learning strategy, we just form our problem by considering the input and the output at the end of the problem solution. In terms of medical diagnosis, for example, we just use somehow input attributes shaping the way of the diagnosing our target medical problem, and at the end we just reach to having the decision of the yes, that medical problem is positive or negative at the target patient, or we may be just saying that yes, there are some for example 3 or 5 different medical problem, and you have 2 of them at the end according to the input values of the attributes regarding somehow an intersection of attributes targeting each of different medical problems, but combining them under the same problem solution approach. So in order to make that solution mechanism to be running effectively, you just be sure about your target problem, about the details or the nature of the target problem. For example, if you have any problems or any small problems in terms of your input data, you may be reaching to the issues of problems of having effective classifications or decision makings at the end, because that may be causing somehow um, butterfly effect in terms of chaos theory. So because of some small changes or small errors, maybe because of the human touch, or maybe because of the nature of the data, because of the maybe nature of the data measuring devices, all of things are happening in terms of gathering data. Because of them, you may be reaching to wrong decisions. So because of that, before running your exact solution steps of your machine learning, for example, in terms of maybe classification here, as you can see, in terms of, for example, the cancer diagnosis oriented effort, you just run some pre-processing, feature extraction and feature selection steps to make the selection of, or the choose of, the most effective and the most important data you can use to train your system and make it to be adaptable, to be applied for the target problem in terms of medical problem, for example. But because we are talking about medical state, and we talking about cancer diagnosis, we are all talking about medical, but that's all same for all of different size of problems in terms of real world. So in terms of machine learning, we have lots of research work efforts for not only classification or clustering or decision making at the end, but also for pre-processing and feature extraction or selection before running the exact solution. But before that, just by determining which data will be okay for us to reach to the decision. It's something like that. A doctor is just deciding to perform which types of controls or checkups to be reaching practical, or to be reaching easily, or to be making decisions about your medical problems easier, depending on the results of the different medical tests, for example. So processing and feature extraction or selection are very important in terms of machine learning. In terms of even scientific works, everybody tries to perform some maybe hybrid methods, for example, or somehow use of different techniques to be having more successful features selection or extraction, selection, or pre-processing steps to make every kinds of machine learning techniques to be running successfully for the target problems. But when we come to deep learning, at the end, for the current state of the 21st century, at least, we just have more advanced forms of the neural networks, for example, or the machine learning side. We just run somehow more advanced forms of mathematics and also logical steps to make the feature engineering or feature extraction or selection sites inside of the technique itself, not by running some different methods in terms of traditional mathematics or different AI-based techniques, maybe somehow an optimization techniques or just different machine learning techniques before running maybe a neural network. But in deep learning, we just use the same technique to perform all the feature extraction, pre-processing steps, and then making classification or maybe regression or other things to reach to the decision at the end. And in terms of cancer diagnosis or medical diagnosis, we generally use classification because we just reach to somehow a decision, as you know, that the patient has the medical disease as positive or negative, and that means the classification. But not always all things should be directed to the classification, but more amount of research efforts are associated with the classification because of the nature of decision making. But you may be maybe using somehow the pre-processing steps again before reaching to decision, but running a big deep learning structure to make a very careful or very important rare disease, or including cancer, for example, to make everything better analyzed before running another deep learning technique in order to ensure the classification of the cancer, but making all pre-processing steps better or successful, for example. So that may be including clustering or other things before the running against to the classification at the end with another technique. So all of these things are just explaining us the main differences among machine learning and deep learning. When we talk about neural networks, we should be just talking about also somehow layers having responsibilities in terms of analyzing or processing the target data coming from the input side. As you can see, there is the image of the medical image, and when we use the machine learning, we should be just using some pre-processing, feature extraction, and feature selection before running the neural networks to make classification for deciding if the input data corresponds somehow a cancer or not cancer results at the end. But when you use deep learning, you use directly your deep learning techniques to reach to the same decision at the end. And that's an important issue that if you, whether you are using machine learning or deep learning, you should be asking yourself to how to train your system, how to test that, or how to reach to the exact real application sites with successful results in terms of retraining and the testing phases. All of these things are regarding to the choose of the model of the problem, because for example, if you miss anything from diagnosing your target problem, you will be probably missing everything regarding true classification or true detection of the medical disease at the end. So you should be careful about modeling your problem so that you can be having enough amount of data shaped according to the model of your problem. Just think about COVID-19, except from the cancer in terms of my presentation. By even talking about COVID-19, if you miss anything, any small things of leading to the accurate diagnosis of COVID-19, you will be probably having many problems at the end, having wrong decision makings at the end. So that's very important issue in terms of medical problem solutions. And maybe in terms of engineering, by just using some wrong information on the missing input states in terms of, for example, a building, establishing a building or designing a building, you may be just reaching to some wrong decisions, which will be leading to be, for example, many dangerous states in terms of building your or establishing your building or structuring or constructing it during at a certain time period. So it's very important in terms of not only medical but all of real world problems affecting our lives. So you should be also determining how to train your system, how many times, which types of techniques or parameters you should be running, or which types of the different formation of hybrid methods, for example, you should be running for effective training. So that's all of these are important problems for machine learning and deep learning. After passing the testing, you will be able to reach to the real world application side, of course, but that somehow in terms of especially today's conditions, somehow how routines and iterative process, I think, according to the changing conditions in terms of your target problem. Maybe you will be gathering more amount of data, more up-to-date data, so you will be always running some training and testing steps in some certain time periods to be making your system to be keeping up to date, to be adaptable to the changing conditions of your target problem. So all of these steps are important for machine and deep learning. And when we come to cancer diagnosis, finally, we should be, of course, talking about the cancer at first. Cancer is, as you know, an uncontrolled proliferation of cells and affecting many different organs in the human body, but not also human, but also animals, many other living organisms in the world. So cancer is a very important, serious, fatal disease. For example, a worldwide statistics of that, for example, all of deaths around the world is because of the cancer, with the rate of the 13 percentage of all of deaths. So that's very important disease affecting different organs of the body. So because it affects many different organs, we need to run many different analyze or treatment process according to changing organs, and so that according to changing types of the cancer, target cancer type. So it's a very important disease. Maybe we will always be having that issue. We don't know yet if something will be appearing to solve everything regarding cancer, like many other diseases. We will all see, for example, about the COVID-19, but cancer is somehow a very different thing, not like a viral or bacterial disease, of course. So it's a very important disease, and everybody is trying to solve an exact solution for that. And even at the state of the treatment process, the early diagnosis is very important for better treatment. And we should be, if we have cancer at the early, before running a successful treatment, for example, we should be always need careful, be screening in terms of the improvement level of the cancers at different types of cancer. So that's very important to track and analyze and to treat that size of fatal disease. And when we come to in terms of computational approach, as you know, the field of medical has gained many important advantages when we get the computer and software technologies in the historical state. Because of running computational approach coming from the computer-based systems, we are all are able to run effective solutions against different problems, needing very careful analyze and very careful detailed evaluations, which cannot be done always successfully by human control, for example. But thanks to computer-based systems and computational approach in terms of traditional mathematics or many different things, including AI, of course, we just reached to a new area of or new era of the humankind, having great importance of digital tools to be getting effective results in terms of analyzing the target data and reaching the successful results at the end. So medical, the field of medical or health care is takes an important place among them. But when we come to the cancer, diagnosing cancer or the running treatment process for the cancer types, we need good data, of course, and we need effective process of the data, whether it's using a machine learning or other things in terms of AI. And we need the computer supported analyze, of course, maybe run off many different computer systems running parallel in parallel state to be having more effective use of time, maybe, or more successful results at the end. And because of all of these things, we just reach to the decision of that appropriate problem. That's an appropriate problem for the intelligence system. So that brings us to the field of AI to be running diagnosis solutions against cancer. When we talk about cancer in more detail, we can be saying that there are lots of different tests for detecting cancer depending on different organs, for example. The most simplest way maybe is the physical tests or physical examination. By just using some physical tests over the body, doctors can be detecting cancers by sensing some abnormal things in your body. At especially that state, you will be maybe having far away level of the cancer, unfortunately, but the physical test is maybe the simplest and most visible or most easier way to detect cancer, for example. But before that, before physical examination, of course, there are lots of different biological or medical tests. For example, there are biopsies, which means cell tests to determine if there are cells causing the cancers in your body, and you can even reach to the detecting the accurate types of the cancer by using biopsies. And also it's possible to run blood tests in terms of laboratory to be effectively getting enough idea about if the target patient has or not different types of, or certain types of cancer. And also imaging, medical imaging is another important component. I think before my presentation, my colleagues, valuable colleagues, have already talked about that. Maybe Professor Nayar from Vietnam has already talked about medical imaging, for example, and other professors have been talking or will be talking about all of these things. And imaging takes a very important place in terms of cancer detection, because there are lots of screening techniques for now in order to see inside of the body, inside of the organs, so that you can be reaching that yes, there are some problems as visible to our system. That so imaging is a very important, taking an important place in terms of cancer detection. And when we come to more details regarding the imaging, we can say that there are lots of different types of imaging techniques in terms of medical. For example, when we talk about the way of the imaging, we can be talking about CT, tomography, X-ray, bone screening, or PET screening, ultrasound, or MRA, for example, depending on different the use of different components to be making visible inside of your body or inside of different organs. For example, by using CT, X-ray, bone, or PET, we just use the way of the transmission, which means somehow, in the simplest way I can explain that, somehow some the invisible signals are passing through your body, and while passing through them, that makes your some of your organs or body components to be visible by some other components taking the effects or results of the transmission phase, so that you can be seeing the exact state of the organs, including bones, including different organs, changing according to the some different components of different transmission-based imaging. And also there is the reflection-based imaging. For example, ultrasound is the most important component of that imaging. By using that, as you can understand from the reflection, from the word of reflection, you just send some signals, including sound waves, for example, and by detecting the reflections, depending on the different natures of the organs inside of the body, you just get some screening opportunities, taking all of these reflected signals by another device or by different components of the same device. So you just reach to the view of the organs, target organs. And by using MRA, you just use the way of the emission of the different particles of signals by because some of cells or different organs of your body shows different the feedback or different the responses against to that emissions of the signals. You reach to more detailed way of the analyzing your body components. By running different approach, in all of these techniques, you just reach to, for example, a screening of slides of your body, or maybe just seeing the whole of the partition of your body by seeing it in a black and white view. And that's important to make some diagnosis, including even cancer diagnosis, cancer detection. So imaging takes a very important place in terms of that cancer detection. And when we come to machine and deep learning scenario, as I've said, explained before, you just have the data. It may be a raw data, it may be a medical image data. Because of the cancer diagnosis in my presentation, I will be giving more the consideration to the imaging, for example, the medical imaging, but whether you have an medical image or other things, you may be reaching to the target training and testing your system, including deep learning especially, without using any feature extraction. And according to the training results of the training and testing phase, you just reach to the application site, which means cancer diagnosis or maybe treatment phases. But because of my presentation is titled as cancer diagnosis, I'm just giving more focus on to the diagnosis. That doesn't mean we just be using all of these scenarios or things for the only diagnosis, but you may be also using many other things for better analyze of the data, as I've said before, or better the detection of the treatment phase in the after the diagnosis phase, for example. So it's all up to you at the end. But when you come to the application site, as seen in the green color, you just be sure about the training or testing phase of the about your target system or the target machine or deep learning system. So you just reach to the application site, but that application site maybe include direct or indirect use, which means direct use for the diagnosis solution, exact solution inside a system, a robotic system maybe, or in a laboratory or environment maybe. But when you use that system in direct use, in terms of direct indirect use strategy, maybe you just run some traditional mathematics or logical algorithms to make be sure that your system is reaching to the solution with the support of the different technological components. So you just run somehow a hybrid methods of problem solving. So that's a simple machine or deep learning scenario, including many different components if you want to examine it in detail. But one of the most important things, maybe difference, as I've said before, between the machine and deep learning is the feature extraction. You may be needing or not according to the deep learning use or the machine learning use, but the feature extraction is a very important component to make your problem to be simpler. At least we think like that in terms of cancer diagnosis. And when we come to the literature about the cancer types of deep learning, which is applied in terms of different cancers, we can see that there are lots of many different cancer types, of course. But when we examine the literature, we can see that there are lots of many research works focused on breast cancer diagnosis, for example. Just you may be remembering that there was a research work from MIT, Massachusetts Institute of Technology from USA, that they have gained or they have developed a system which is able to diagnose breast cancer before it appears 5 years before it appears exactly. It's very successful. It was very successful results against real doctors, for example, real ontologists, for example. And the breast cancer is not only this one successful results in terms of especially AI or deep learning in detail, but there is also some successful results against real doctors in terms of skin cancer, for example. And there are lots of many different successful results in terms of especially early diagnosis, which is very critical for detection of the cancer. And when we talk about breast cancer, lung cancer, brain cancers, brain tumors, especially cervical cancers or liver or prostate cancers, we all have successful results in terms of early diagnosis and in terms of high number of accuracies at the end. As like machine learning techniques, we use some certain evaluation metrics to reach to some decisions about accuracy, sensitivity, or specificity of our system. So all of these results, depending on the different research works, there are lots of research works because of that I have not listed them in my slide, but you can just Google them over the Google Scholar maybe, or go over the Google or maybe other search engines. We don't know, but we always say Google. But you can be reaching most of the research works in terms of breast cancer, lung cancer, brain tumors. That's a very important and critical research trend nowadays, detection of brain tumors especially. And there are some still hidden or very rarely examined cancer types, like cervical cancer maybe, like or liver cancer maybe. So you are all free to search for them, and not only humans but also for animals, for including, for example, dogs. There are lots of research works which are using deep learning for cancer diagnosis, and some of research works of some of all of these research works may include also treatment phases or some pre-processing phases to make the other steps maybe will be done by the real physician, real doctor, or maybe other components to make their easier to be understanding better about the input data in terms of medical image or other things, depending on the target cancer type. So you are all free to search for the literature. I will show two of important article during my presentation. For example, one of them is that by Munir et al. It's called as Cancer Diagnosis Using Deep Learning, a bibliographic review. There are lots of research works, there are lots of publications, but for a general review, you may be taking a look at to that publication. I will show that. And according to that publication and according to many different research works, we can say that the deep learning is applied in terms of cancer diagnosis by using three main steps, which includes pre-processing of the data, image segmentation of the data, and post-processing, including the other things, making your image data especially better for the deep learning capabilities, or maybe the other steps of the deep learning can be accepted under the umbrella of post-processing. When we talk about pre-processing, is just somehow some image processing based methods to make your data, your image data, to be free of the noises, for example. That includes, for example, different approach of adjustment of the contrast, remove of the vignetting effect, as we see in images in photos, for example. So that may be resulting to misclassification or incorrect classification or incorrect decision making for the deep learning system. So you should be running some that's remove of the vignetting effect methods, or you may be needing the correction of the color at that point, or you may be making image smoothing, and even hair removal, for example, is very important, because any small pixels of that hairs may be resulting to incorrect classification or problems at the decision making side in next steps of the deep learning technique. So all of these things are just for removing the noise or unwanted things from your medical image especially. And normalization and the localization is also important because while even detecting a car from its plate numbers, for example, you do not need to look at to the color of the car maybe, or the tires maybe, or the driver inside the car. If you want exactly to determine the numbers or the letters over the plate of the car, you just locate the exact thing as to the plate, and your cameras or other things to make having information about the letters or numbers over the plate just tries to run some pre-processing steps, which just takes crop, for example, the plate from the car photo, and run the other steps to make the recognition of the plate or numbers or the letters over the plate, for example. So pre-processing is important at this step. As you understand, I'm just running my presentation through to medical imaging for the cancer diagnosis, because that takes a very important place. Of course, there are some research works targeting the raw data, or maybe, for example, some characteristics regarding to humans, or maybe blood tests, numbers of blood tests for detecting cancers. But the main thing is the automated cancer diagnosis thing, is the analyzing or making diagnosis from medical images. That's the maybe the 80% or 90% of the research works are taking place in terms of medical image analysis for now. So I'm all of my presentation is directed against them. And of course, the deep learning may be requiring that because of their nature, especially the nature of CNN. I will talk about that in terms of image processing. And anyway, and after the pre-processing, we run image segmentation. Image segmentation is just making your target image to be understandable in different ways by just making your image to be understandable in terms of different segments over the image by running different image processing techniques. By running image segmentation, you just make your deep learning techniques job easier to, because your target medical image is segmented into different regions, into different areas, and that makes easier to the understanding any problems or any normal things appearing in the medical image of the target organ or target region of your body, of the patient's target body. So that's an important side after the pre-processing. Pre-processing is just removing the noise, but image segmentation is just somehow making the segmented image partly to make your job of your deep learning technique better. And image segmentation includes many different things, including even supervised learning and even use of fuzzy logic, for example, or edge detection. As, for example, Professor Hemant has introduced or explained at the start of the presentation, edge detection is important. And even clustering or active contours or region identification takes important places. All of these are just like running over the Photoshop, like running in the simplest way to explain, running some different filters over the photos or over the different images in the Photoshop environment. But when we talk about deep learning or AI, and also especially cancer diagnosis, that's a serious thing to run such things. But all of these removal of the noise and image segmentation make your post-processing steps better. And post-processing steps includes again the different types of methods, including island removal, region merging, for example, or border expansion, to make your job of your technique easier and easier. All of these things are important to make your system's jobs easier. All of these things are critical needs or explanations of why we are doing all of these steps. I'm not focusing on in details all of these components, but you are all free to read to the target reference work of many other things taking place over in the literature to be having more information about all of this process. For example, in terms of understanding the problematic side of the organs, there are lots of different methods. There is the ABCD rule, for example, or other things to make to be sure problematic sites of the target image, medical image, or the normal states of the cells of other things over the examined image. And all of these methods give you some advantage of running different the problem solutions depending on the target's cancer types. But the future will be probably requiring more use of different things or different rise of different components to be sure against different types of cancers or multi-cancer diagnosis. Maybe I will be talking about them in my next slides. And when we want to make something visual in terms of the deep learning, we can be just give that as an example. For example, you have just a whole slide image as the samples of tumor or normal cells, for example. You just make your deep learning techniques to be trained against all of these cell types. And after that, your system has some weights in terms of neural networks, for example, have some weights and some adjusted or optimized components to be detecting some tumor or normal image-based things over the testing image, for example, or the real application sites, maybe, to be having idea about overlapping image page, so making a tumor probability mapping at the result, for example. But in order to ensure that, you should be training your system against all of possible different types of cells, including tumor or normal cells, for example, so that your system will be able to detect any other or any problems in terms of cells by taking a look at to the testing image or to the real image. Which means, of course, the training, that doesn't mean training includes some synthetic data, but you just show some image or testing image which we already know about them as the humans, but you just try to test your system if it can be effective enough to understand enough about the tumor or normal cells from your target already known image, so that it will be able to diagnose cancer from newly encountered images at the end. So that's an important, simple way of the deep learning, apply of deep learning at the detection of cancer images. And that's another important paper you may be taking a look at. That image is from that. By just running, for example, a CNN, maybe CNN convolutional neural networks is important because it's as somehow successful results, image processing sites in terms of big data, big amount of image-based data especially. That doesn't mean you cannot use CNN for any other different types of data, but you can be running that CNN, that types of deep learning for especially image-based data, including image, satellite image, including medical images, including, for example, detection of objects from satellite image, or detection of disease from medical image, of course, or detection of objects. Just think about YOLO algorithm or the CNN used in self-driving cars, for example. So that brings us that according to the literature, CNN seems to be a very popular deep learning techniques that's very widely applied in especially cancer diagnosis. When we just get a sample with label encoding, you should be making these segmented or these all of these cells images as the normal or tumor cells, for example. You should be encoding that as at the end. So after feeding your system, it just uses some convolutional layers or pooling layers and also fully connected layers, similar to the traditional neural networks, MLP, for example. And by just running, for example, convolutional layers, your system is just able to determine some features from your target image by analyzing all of the pixels or details in your target image. By using different filters, it just makes somehow a numerical representation of your target image to make the other jobs of other layers coming next easier, to be detecting very detailed features or very deep details, as like it appears in the name of the deep learning, to be detecting your cancer, for example, at the end, or your target problem, performing successful classification or detection over your target problem. And after running convolutional layers, you just reach to, maybe it depends on your modeling of your, of course, CNN model, you just reach to maximum pooling layer, for example. So it just filters the most important numerical values coming from the convolutional layers to make your data to be less taking time analyzed, or the less difficult to be analyzed and that's just be connected to the fully connected layers maybe at the next layers. So you just reach to the decision of that image includes tumor or normal cell. So all of these are just in terms of mathematical and logical side are represented with some numerical calculations, included weighted values, including use of kernel functions or activation functions, which are just optimizing or just adjusting the way of your most important or less important data to be going through to the layers to the end, so that your system can be detecting which has the highest priority, tumor or normal, so that it leads to a decision about your target image. In terms of, for example, learning steps, you may just run a backpropagation method to be backpropagating your error during the training phase, because when you show that the image as a training data, saying that yes, that's tumor, but let's see if our system will be saying it's a tumor or normal. And if it says normal, you just run the error, the difference between the desired output and the reached output currently, so that you just adjust the weights or other things taking place in your neural network to be more adaptable to the target input. But that's not only for that data, of course. The whole system is applied against many other cell images, for example, so that it's your CNN system at that sample at least has been trained enough, has been having enough values of weights to be adaptable to be detecting the target cell as tumor or normal cell. And we can talk about more samples, of course. So, for example, at the training phase, just pathologist just identifies regions of the interest in whole slide image and labels their category by taking a look at to that, for example, brain tumor diagnosis, for example, just by labeling the regions as normal brain, or glioblastoma, you just reach to small image space from the region of interest. Just think about glioblastoma, for example. You just take that small image pets, and each of your small image pets are just fed into the CNN as an example. That may be another technique, of course, but the CNN is the maybe the simplest way of the explaining the way of the deep learning at that scenario. And after that, according to the target labels, for example, there are lots of different targets, not only positive or negative tumor or normal, just two classification, but there are 4 different classification here. You just train your system here, and according to that, according to the training step, your system will be able to determine any of the problem in your target cell according to the trained system and according to the newly encountered cell image, for example. So that's another sample of the training as CNN system for the cancer diagnosis. And when we reach to a bigger scenario, in terms of cancer diagnosis, we may be just reaching to such a scenario as explained by Levin and his friends. For example, patient presence with seizure and neuroimaging is accurate at first, and radiology computer-assisted design system identifies and segments the abnormality automatically by not requiring the detailed touch by the maybe doctor, real doctor or physician, and generates different diagnosis and preliminary report according to that. And according to the tumor infarct abscess or encephalitis, for example, according to all of these findings, cases treated for high priority review by radiologist maybe. And radiologist reviews the image and modifies the report as needed. Here there is a touch by the real radiologist, for example. And according to that, the patient is referred to the neurosurgical service and undergoes research of the tumor. And that tumor is sent to the pathology department after that. And the pathology departments are just scan all of the sample, and according to the sample is just run through the CAT system, which includes maybe a CNN or any other deep learning technique. You just reach to the findings by the other system to be having a final diagnosis and the report. You can see that that's the role of deep learning here, just includes the important interaction among the computer-based system, including the deep learning, or maybe a simple image processing step at the early stages, as you can see. But that's a very important relation between the real component, real human, I mean the component is human here, and deep learning technique as the computer-based system. And when we come to literature about the techniques, each of techniques in terms of cancer diagnosis, we can see that there are lots of applications of CNN because of its high results, high successful results in terms of CNN. And there are lots of different research works regarding that CNN and many other variations, including different use of different image processing steps or other components to make your CNN to be running more effectively against the target problem. So CNN is very effective in terms of especially medical imaging analysis, so that's cancer diagnosis, including of course the medical imaging is used or made already the use of CNN often in terms of biomedical research and in terms of cancer diagnosis. And there is the deep belief networks, another component, but according to research work, CNN seems to be giving better results in terms of especially very detailed image analysis of some certain cancer types. But you are all free to, of course, use of deep belief networks. Deep belief networks seems to be having better results in terms of raw data, including blood tests or other things, as I've said before, but not directly the medical imaging. But CNN seems to be a better. But of course, some publications may be hybrid methods with deep learning belief networks, maybe including some slightly better results, but the general findings seems to be making that CNN overcome deep belief networks for especially medical imaging based cancer diagnosis. And there are also autoencoders, the third component, which means the making your data representation in a simpler way or in a changed way, which means somehow an encoding or decoding as the model of that neural networks includes same number of inputs and outputs, because making your complex input to be simpler at the end. So in terms of cancer diagnosis, that's generally used for especially making your data simpler or more understandable for further diagnosis, or making your data to be better understandable by the real doctors at the end by making a simpler representation of your system. So autoencoder takes such place in cancer diagnosis. There are RNN, recurrent neural networks, and LSTM, but they are slightly applied, I think, in terms of cancer diagnosis, because such systems includes interpretation of the past known samples, which means, for example, you can run such systems in terms of especially language processing, natural language processing, or maybe signal processing, which includes some clues in terms of past known image data, sorry, not image, signal data, but in terms of cancer diagnosis, of course, you can be, or research works are generally focused on running such systems in terms of prognostic detection, or making some diagnosis regarding the real-time level of the, for example, the cancer diagnosis of your target problem. And when we, sorry, Professor.
Continue, Utku. No issues.
Okay. Thank you. But
maybe another 10 minutes.
Yeah. Sure. Just it's finishing. Yeah. Sure. Yeah. Okay. And also when we talk about, for example, generative adversarial networks, research works are directed to the generating synthetic data in terms of especially, for example, better cancer diagnosis and generative adversarial networks, because I left that at the last explanation. It's a very important the neural networks system for creating, for example, the synthetic the data, which means the use of producing data for better diagnosis or better results at the end. And cancer diagnosis seems to be having using generative or GAN briefly for synthetic data creation of or making somehow a visual representation of the cancer parts of the target component. And when we come to evaluation metrics, we just use ROC curve, accuracy, precision, recall, specificity or scientificity or precision in order to determine the performance of your system. For example, I would like to show you that paper. Just take a look at that, or there are lots of papers, of course, but I would like to just that because it's a recent one, I want to show that to you. You may be just having enough information about all of technical details, for example, evaluation sites. Just read about that. It's called as cancer diagnosis using deep learning, a bibliographic review. Also, just take a look at to the page number of 24 and 25 for reaching to a collection of data sets, because data sets is a very important problem for the cancer diagnosis. And just take a look at to the paper and take a look at to that paper. The other paper I'm just gave some explanations regarding the image in my presentation. That's another important paper. Just read some from Nature, the Journal of Nature, to have some important information. All of these are important to have more information after even my presentation. Yes, I'm just reaching to the final. Let's talk about future scenarios. The future will be probably having a multi-cancer diagnosis with deep learning. Maybe deep learning and IOHT, for instance, checkups for especially cancer will be a very common thing in the future. Fully automated diagnosis treatment is important. Robotic systems, of course, for cancer treatment especially is very important. Explainable AI has an important place, or ambient intelligence has an important place for the future. And environmental factors to analyze with the DL, because we just we just analyze the target's problem for now, but maybe running some analyze against environmental factors for cancer diagnosis maybe. And also there are global official data storage problem for intelligent diagnosis that may be a future scenario for the future. Maybe synthetic data creation is will be another future scenario for the future. And health tourism for cancer. Health tourism is an important after, especially the COVID-19, for example. But the future maybe includes health tourism. Health tourism is another component, of course, to research. But I would like to just take an interest to that concept for especially cancer. You just fly to the USA during a day, and by just having your maybe treatments, you just come back to the India or to other country. And that's an important health tourism, and that should be or will be controlled by the run of advanced forms of intelligence systems running over deep learning especially. And explainable AI will be a very important, because for now we should be trusting the intelligence systems about their decision makings. But the XAI, the explainable AI, is an important concept, because there is an explainable model which includes some interpretations for explaining how the system reached to some certain results, some certain findings. So explainable AI will be having a great importance for future scenarios. For even now, you may be reaching to many different publications about that explainable AI. And considering the IoT, also sensors or many other components which will be common in the nature, the ambient intelligence, it's not a very new concept, but the ambient intelligence will be a very common thing, including for especially cancer diagnosis, tracking, or treatment. And when we come to open problems, of course, in the future, data sets, combination or gathering of data or sources for data will be always open problems. So you can direct your research efforts to that, especially. And also new techniques, deriving new techniques or solution approaches will be another open problem. And prognosis detection is a very important problem as an open problem for the cancer diagnosis, because prognosis detection seems to be having not very successful, or have some successful results, but not too much like we done with CNN in terms of cancer diagnosis. But in the future, that will be a very important open problem, so you can direct your research to that issue. And early diagnosis, of course, in terms of cancer is very important. Expert knowledge to be applied in deep learning is very important. Maybe we will be having open problems because currently we have many research works for alternative imaging. Understanding the imaging for better analysis of the deep learning takes a very important place. Explainable AI, very important, as I've said before. And systems against cancer factors is very important, because we just take place in terms of diagnosis and in terms of treatment. But what about eliminating the factors before reaching to the problem, exact problem? So deep learning may be having a great importance in terms of analyzing big real data coming from everything you did or you do in your daily life. Just think about COVID-19. You use data science to be tracking the social distance or other things, to be having to inform about the spread of the virus around worldwide, for example. So that can be a very important component to be against cancer factors before reaching to the cancer exactly. And gen analyze for cancer is very important. It's another thing to for diagnose. I am not included in my presentation, but it's an important open problem. Data privacy is another important problem, because COVID-19 has appeared that's more visible, and because of the cancer diagnosis, that may be another important component. Formation of hybrid systems will be a remarkable open problem, because even now, in present time, we run different hybrid systems to run effective solutions for very difficult problems, including cancer diagnosis, and we gain some advantage of running less time, running systems, or having more accuracies in terms of cancer diagnosis or many other medical diagnoses. And I would like to give some final suggestions for especially student friends. You can be learning more about cancer diagnosis and treatment in terms of medical sides, not deep learning or AI side, but in terms of learning something about medical sides, you will be more able to understand how to apply deep learning in terms of cancer diagnosis or treatment. You can be keep yourself up to date about AI or cancer diagnosis by reading publications about AI, or reading about AI from news, blogs, videos, newsletters, of course. I think you will be all adaptable, or you will be all aware of all of these things. But many others, among many other things, one important issue that learn algorithmic details of AI or deep learning techniques and write your own codes at first step. Do not use libraries directly by considering for example, TensorFlow or Keras in terms of Python environment. Just try to write your codes manually. After that, you will always free to use any other ready libraries for better use of time, or less writing codes, so that you reach to certain results. But if you write your codes manually at first, you will be adaptable to be learning about logical background, so that you will be all learning enough about new techniques or new things to be appear in terms of cancer diagnosis with AI and deep learning. And also you can be learning about some data science and statistics, because numerical values, numbers are very important in terms of AI, and mathematics and logics are very important, but do not fear about them. Just try to be adaptable to them while learning about the details of the AI. And you can be choosing subfields to work in AI and cancer diagnosis, like maybe gen diagnosis from gen expressions, maybe, or maybe prognostic diagnosis, or maybe a specific type of cancers to be working on. That's up to you, but a valuable suggestion by me. You can be joining to events, training programs, or online courses like that, and you can be following famous scientists around the world. I don't know if I'm famous or not. I'm always saying that at this point in my webinars, but you can be following famous scientists working in the cancer diagnosis. You can be following, dear my friend, Professor Jude Hemant, because I know good publications from him, and we have common publications, of course. And you are all free to follow famous scientists from the department, of course. And you will be all ready to learn everything and to be up to date about cancer diagnosis and use of AI, and of course use of deep learning for now. And we will see, of course, what the future will be bringing. So that's all. Okay, thank you very much. I hope that my presentation is not giving many detailed explanations, but your questions are all free to be answered by me. Yes.
Thank you, Dr. Utku. A beautiful presentation, as beautiful as Turkey and Isparta. Thank you very much for your informative session. Just a thing which attracted me more is the stress on no feature extraction for deep learning. So most of the early researchers make mistake in that. They still use a manual feature extraction, which is not exactly necessary for deep learning. Other things you pointed about the pre-processing steps, the procedure for implementation, rather going into the algorithmic view, you came on the other side to give the how to deal with the practical procedure for implementation. That is very interesting. And fourth one is the explainable AI. Neural networks and deep learning seems to be a black box so far now. So researchers or professors, if you're interested in explainable AI, it is a very large booming area. And the last one I am very much impressed is write codes first. Don't use libraries. That is what an expertise or a researcher can gain expertise out of that. If you keep on moving with the libraries, that you will face problem. That's why I told in the introduction section, you can try with JPEG images where in MATLAB or any software, you can write your own code. Now, we quickly will go into the question answer session. I know many of you will be having many questions. I will request Dr. Anushya to take over the question answer session.
Yeah, thank you very much, dear.
Participants, if you have any questions, you can post them in the chat window or you can directly ask Professor. We have a first question. Will there be an efficiency improvement when we change the training algorithm of the network?
Sorry, because of the voice, I couldn't hear, but is it written over the chat site, dear?
It's actually been sent privately to me, sir. I'll read it out again.
Anushya, your voice is having some echo. Can you repeat once again?
Yeah, sure, sir. Am I clear now, sir?
Yeah, repeat.
Will there be an efficiency improvement when we change the training algorithm of the network?
Will there be any efficiency improvement if we change the training algorithm of a network?
Yeah, sure. Because there was a voice effect on the background. I couldn't understand. Sorry for that. When we take a look at in detail to the learning algorithms, there are many different advantages or disadvantages among different learning algorithms. So that affects, of course, the way of the training steps of our neural network. For example, even there is the issue of the overfitting problem, which means your system can be effective to be learning similarities or relation in your training data, but not learning enough about how to solve the target problem. So use of different training or learning algorithms may be affecting even that. And by using different learning algorithms, you just try to eliminate that issue, and you just reach to some more amount of training time. So you should be just be trying to seeing that if which learning algorithm will be effective for your target problem. Of course, there are some of target of some of widely used training or learning algorithms which are widely used, but at some sites, some choose of different learning algorithms in terms of, for example, traditional neural networks in terms of backpropagation or using Bayesian regularization, maybe changing many things in terms of having good results for your target problem. So it's up to do your experiences and up to overfitting issues that you may be encountering in your target problem during your target problem solution process. Of course, the modeling of the network will be affecting. So that's an important open problem, as I've said in my presentation, that modeling uh, the system, neural network system, and determining which parameters, which algorithms to be used for learning or training are very important components. So you should be optimizing them. You should be choose another real-world based optimization problem to be detecting which is best with the other one. So that's all.
The next question is, what is the difference between prognosis and early diagnosis?
Yeah, prognosis, early diagnosis seems like a better advantage for providing a better treatment or early treatment, which will be not very difficult for the target patients. But prognostic seems to be something, maybe, of course, be touching with the early diagnosis, but it gives some idea about what is the percentage of being treated against the target cancer, for example. So when you make an early diagnosis, your prognosis rate will be good. That will be show that you will be safe after a while if you get enough good treatment at least. But when you get somehow not an early diagnosis, you will be even have a good rate for in terms of being survived against the cancer type, because it depends of the run of the treatment process. And because of that, while running the treatment process, you run just prognostic tests to be sure that you will be able to survive or not about your cancer. So they are very common, seems to be common things, but very important and different things to be examined. Yes.
What is underfitting?
Underfitting means, overfitting means the being and the understanding the everything about the training data too much to be so that your system cannot be giving enough results against the newly encountered system. But underfitting seems to be not learning enough about even training data, so it will not be very successful in terms of not having a very high priority or very high rates against the training data, but not being too much learned about the target data.
Okay.
Yes.
We have a question, Dr. Utku. If I may, how will deep learning going to improve the cancer diagnosis when we are dependent on the humans for data sets? Can we overcome this challenge? How deep learning will improve the cancer diagnosis when we are dependent on the humans for data sets?
Humanless data sets, you mean?
Because the human beings are going to supply, the doctors are going to supply the data sets. So he is asking how deep learning will be improved, because it is going to again depend on the human beings for the original data. Can we overcome this challenge?
In terms of, you mean using synthetic data, you mean? Yeah. When we talk about the synthetic data, of course, that's a very important issue. That's very maybe a paradoxal state that you should be having enough idea about how the real data is flowing, or how the real data is changing according to the nature of the human. But it's not very possible to understand all chaotic nature of the humankind, of how that all of these data is created, because we even do not have enough about even our brain or many other different organs, even about expressions of the gene, maybe many details. So that maybe synthetic data will be probably including important human errors, which means not hitting the target way of the creation of the data naturally, maybe. So we should be running additional maybe data processing things like removal of noises, as I've said in the pre-processing steps in terms of image data. But that brings us to many different sub issues, open problems, like if you create some synthetic medical image, you reach another issue of how to remove the different errors in terms of image processing or image-based problems. And when you reach to raw data, maybe a blood sample, synthetic data of blood samples, maybe you may be getting some additional or requiring additional analysis for future predictions that if your data will be affecting the way of the learning side of the deep learning, or causing it to be having some problems in for features in terms of for time period. So I think we will need more use of mathematical and logical additional algorithms to be trying to be eliminating that issue. But synthetic data will be probably and necessary for the future, because as the humankind, we are not reaching to the exactly, I think, according to me, the rate of the creation of the data in real time, thanks to social media, thanks to many other things, thanks to COVID-19 maybe for now, because it has become an important massive issue of medical issue that we will be probably having worldwide medical treatments or diagnosis systems in the near future. So synthetic creation will be a common thing, but we should be dealing with additional human errors or data errors, I mean, to be detecting and eliminating them for better results at the end. Yes.
One last question. What
Sure.
is radiogenomics based cancer research?
Genetic, can you repeat what is genetic?
What is radiogenomics?
Radiogenomics. Yes, I remember that radiogenomics, genomics, and in terms of especially use of the genetic the identification, maybe, and when we talk about also treatment also of radio-based the treatment approach, when we combine all of them, we just reach to radiogenomics treatment side. So radio genomics maybe also having relationship with also with, for example, image-based data, to be having enough idea about how to the genetic or molecular features are appearing for better diagnostic or better decision making at the end. So it's will be having a very importance in terms of especially cancer diagnosis. So that maybe, for example, explainable AI or better diagnosis at that. So by just the improving the image processing with that site and the genomic genetic terms evaluation analysis, we just reach to different types of how can I say, analyze for diagnosis or treatments at the early stage. I remember that like that that term. Yes.
Thank you, Dr. Utku, for joining us. Thank you very much for your informative session. I hope all the participants would have enjoyed the day. They would have got some useful information for their research career also. Thank you once again. Yeah. Now I request Anushya to give the closing remarks, any instructions about tomorrow's timings.
Yeah, so participants, you can fill the attendance form. It is posted in the chat window right now. And tomorrow's session will actually start at 2 p.m. instead of 11 like usual. So tomorrow, please join us at 2 p.m. So thank you so much for being with us. Thank you.